So let's go with it here. So this is a review of chapter 2-ish, right? 2.1 to 2.5. So let's go with any homework questions you guys have or any concept questions. So Abe.
So I had some questions that I turned in 2.1. Because a while ago I asked you if we could go over some of the problems. Instead we could go over them today on the review day. So then I didn't put anything on them. Then I got marked.
I'm so sorry. Okay.
No, that's fine. I was just wondering, could I like fill this in? And do
absolutely. Yes. In fact, I had some questions off of that too here. So give me 2.1.
Yeah, it's 65, 69, and 70.
65, 69, and 70. 75, 73, 79.
79.
79. Okay. Dylan.
I had 105 on the
2.5, 105. Okay.
So I think 63 off of 2.5 as well.
Okay. Wednesday, on Monday, Yeah, we'll do a review today. We'll finish up review on Friday, test Monday. Okay, anybody else? Going once, going twice. Okay, so let me do this here. As we bring this down a bit.
I think this is just coming back to my mind. I also have questions. I don't have any homework version, but I have questions about the last two on like 2.3, I think. Like 55 and 59 and 2.3. It might have been 2.4. Whatever chapter is the synthetic division.
Synthetic division, okay. That is 2.3. So 55, 59. Okay, so lots of homework questions here today. So Miss Rain, sorry, you may just sit up for homework questions for a little while. Okay. All right, 2.1, let's go through it here. And a good review as well. And I got another question here for you guys. How many have a graphing? You have access to a graphing calculator at home? Do now, okay, because I saw that on the homework as well.
I do now, but I cannot figure out how to work it.
Okay, which calculator do you have?
Starts with a T.
I like a T90.
Okay, so bring them in if you need to, and we'll talk. Or there's something called YouTube, which is pretty cool too. But if you need the help, come on in. I'll let you guys finish up. And then Dylan.
I didn't speak today.
Yeah, so how it works.
I also have 1,200 pounds of cheese in the back of the truck, so I couldn't speak. Or else I'd yell at me.
Okay.
I gave my phone to my dad in the car. Hopefully he did it. He wanted to put 700 and like 30 degrees on there. Yeah.
All right, let's go with it here. 2.165. It says find two quadratic functions that goes through these 2 points. So this one would be good just to graph it a little bit. So you have these 2 points. You have a quadratic function that's going to go through both of those. So -1, 0 is going to be right here. 3, 0 would be about right here. And so let's work backwards here. So, and if you know that -2 is an answer, what's the factor? -1 is a solution. -1. X plus 1. Perfect. Okay. Boom. Of course I'm going to bug you here. So Maddie, 3 is a solution. What's the factor? Perfect. I taught you guys well. All right. So let's go with it here. The only thing we don't have is this little a value here. So notice our factors are over here. The a value, remember, tells you how steep it is or how wide it is, right? And in this one, it says find 2, because there's a whole bunch of them. Notice we can do this one right here. We could do a wider one like this.
She did it in there.
Okay, and I did check your temperature on the side here.
She just checked it too.
Okay, she did. Awesome. Okay.
I'm 300 degrees.
All right, warm today. Slightly warm today. All right, so let's go with it. So we're going to multiply this out like this. Just FOIL it out. The a value, we're going to keep it as a 1 for the first time through. So when you multiply this out, this should be x squared. This would be minus 3x. This is plus x, and this is minus 3. Let me just kind of do it real quick here. Ask me the questions. And I'll stop there just for a little bit here. So this is a being a 1. You could have multiple lines through. In fact, there's a whole bunch of different lines you can cause to go through here. All based upon the a value. So a value makes it steep or makes it wide. And so that's just one answer. Let's say this one is this one right here, x squared minus 2x minus 3. We're good? That's that one there. All right, it says one that's going up and then one that's going down. So all we do is we do the same thing except just pick another value for a, but pick it to be a negative number. And -1 usually is the easiest one to do it. So here's one answer for the homework. The other answer is what you do is you just multiply through by negative. You say, look, if I'm going to use negative a as a number, here's me multiplying through with a negative, then it becomes negative x squared plus 2x plus 3. How we go? There's my other one. Now on the homework answers, it says answers may vary, right? Or answers vary. That's why, because the a value could be anything you want. If you want to multiply by 2 all the way across, that's cool. By 3 or -3. So you're going to have all these different variations. Dylan?
So on the homework, I was thinking with the solid graph, there was like the one right after. You said that I need to be more specific on my graph. Or like just because I didn't write out the actual equations. Or
For which one? On these?
yeah, like on the you commented saying like be more specific with the graphs. Was that just saying like write out the equations or like?
Oh no, I just wanted you to graph it. Just graph it a little more precise on the homework because it was kind of just went through. Okay, we go there. 65. 69, a little bit more complicated because it's a fraction. So let's go with that. 69. It says -30 and -1/2 0.
Just to be clear, we are trying to find any given line that goes through those two points, right?
Yeah, for these ones here, so what we're trying to do is we're trying to find one that opens up. Here's your open up one. And then we're trying to find one that opens down.
And that's determined by the a value, whether it's positive or negative.
Perfect, yeah, all determined by a value.
I don't think I agree.
Gotcha, okay. One that, yeah, says to find 2 quadratic functions, one that opens upward and then one that opens downward. Okay, so a little bit more complicated now. That's what makes it complicated. You got a -1/2 right over here. Should be 0. They have to all be zeros because we're crossing the x-axis. So here it is, my beginning value here, f of x is equal to, and let's see, Charlie, all yours. -3 is my solution. What's my factor? Okay, and the tough one. Who should we get? Tristan, I'm going to give you the tough one. -1/2 is my solution. Okay, x plus 1/2. Oh man, we're gonna have to multiply with 1/2 inside it. Perfect. Okay, cool. That's what I was waiting for. Oh, and how come you can turn this into this?
Well, because if you multiply, are you saying like why does it turn?
Yeah, the y question. Yeah.
I don't actually know why that's allowed. I just know that I've worked in the other direction before.
Correct. Yeah, Maddie.
Well, yeah, but why?
Well, because if you keep solving it, you can divide by 2 and you just get x plus 1/2. So it's the same.
Cool. Okay, that's cool. We'll go with that. So if you say x is an answer, right, and you work backwards from that answer, you multiply by 2, you get 2x is equal to -1. And if you were to add 1 to both sides, you get that little, remember we call it a 0, right? That's a 0 to us, right? And so you could either work backwards from our solution, or what Tristan did, he just put in that answer right into there, right? It's the opposite of our answer for our factor. Both of them work just fine. Tristan?
So like if you had 1/3, you could just times both sides by 3.
Yeah, let's say a positive 1/3 was the answer, right? Was a solution, and so we would multiply by 3 here, make a 3x. In this case, it's going to be a subtract 1 to get us to the 0. So then 3x minus 1 would have been the factor that goes in. We good? Okay. So all yours. Landon, let you decide. Do you want to multiply by x plus 1/2, or do you want to multiply by 2x plus 1?
2x plus 1.
I think so too. Why multiply by fractions if we don't have to? So that's the preferred factor to plug in. We good? All right. 2x squared plus x plus 6x plus 3. Voila. Yeah. You guys check me. Make sure I did it right. Make sure I'm not tricking you. Okay. There's one of my answers. That's the upward facing one. Landon, how come I know it's the upward facing parabola? Why?
Oh, because there's the a, we're just having the a value equal to a positive.
Yeah, my a value is, in fact, my a value is 2 this time, right?
Yeah.
A value is 2 over here, which works out perfectly, and it's a is positive, a is greater than 0, therefore it is facing up. All right, Annette, your call here. This is the upward facing parabola. How do we make the negative facing parabola? Multiply through by -1. Can you give me the answer? So if I were to multiply this against a whole new function, in fact, real quick here, guys, real quick. Can I redo this here? Let's talk about some math stuff. So if I say f of x is equal to this equation, right? And then underneath it, I say f of x is equal to this equation, good or bad? Isabel says, yeah, no. I think that's was that a yes and a no at the same time? Yeah, no? That was a no, okay. Dylan? Okay, yeah, you can put negative x, or if you want a whole new function, which you can use, you could just use another letter. So it'd just be g of x. You say, hey, you know, f of x is this, g of x is this, and the next one that we normally use is h of x. Those are kind of like the 3 initial functions we use. So g of x is, Annette, multiplying through by -1, give it to me. Ooh. Okay, let's see. Let me see what you said. What? Negative 3x squared? Minus 2x. No, because I think, let's see. Let's go through this here. So all we want to do is we want to make this little guy right here a negative. That's all we want to do. You can either multiply by, yeah, you can multiply by -1 all the way through. We can multiply by -2, -3, whatever you like. So what number do you want to multiply through? Yeah, -1. Let's multiply all this by -1. And all this is going to do is going to go -2x squared minus 7x minus 3. So notice that everything here is just negative, right? We have to negate all the signs there. On the homework, Dylan, Tristan, 1 second. On the homework, what I found a student, won't name names here. They got this answer, and then what they did is they put down that is the next answer. What is wrong with that? Yeah, the negative has to run all the way through, right? It's a multiplier of a negative, right? So you have to change all the signs. It has to be a multiplier all the way through. Dylan, go ahead.
So for the positive equation, you said that 2 is the a value. So does that mean that 2 is just the multiplier of the first coefficient, or does that of the first x, or is a distributed to every single number?
No, a is just a multiplier of the x squared. We say this is called a leading coefficient. I got some good vocabulary here. Yeah, always the number in front is the most important. There you go. Isabel says that whenever we write equations, we write it as a. There's my a value, ax squared plus bx plus c, and that's the a we're talking about right there. Tristan?
So, like in the beginning, when you times one of the
Yeah.
By 2, do you ever have to divide that to 2 to get it back to whatever it is?
Like getting rid of this 2 here. Whenever we don't ever have to divide it by 2. We don't ever do that. Not part of it. When we solve for, remember we did 2.1, we were trying to get it into a graphing form. We sometimes factor out the 2, but we never divide out the 2. Okay, guys, real quick here. Go to 79 now. 2.179. All right, now we got some application questions here. We have a manufacturing cost. What? Math in real life? No way. This is so cool. I have, let's see. I have a relative. Let's see. I'll just call him a relative that lives in Germany. He is CEO of the boxing company. He makes boxes. That's all it is, packaging. It's a packaging company. And so we were talking. He deals with equations all the time. So he's actually one of co-CEO. How about that? And cardboard boxes, any boxes shipped out of Germany, usually that goes internationally. His company has done the boxing for it here. So German chocolate, all that stuff here. And so for him, this whole concept of manufacturing costs and everything is every single day stuff, because he has to know the total cost in dollars. Let's see, we're manufacturing lighting fixtures, and the daily production costs are given right there. X is the number of units produced. How many fixtures should be produced each day to yield a minimum cost? Oh, wow. Yeah, go ahead, Dylan.
Can you just say that again? It's like I'm trying to get this down the font.
Oh, the problem itself? Yeah. Sure. So this is daily manufacturing costs. And we want to know what is the minimum cost. And let's see. Let's do this here real quick here. Owen, is this a upward-facing parabola or downward-facing parabola?
It's up. Wait, it's downward. No, it's upward because the coefficient is above 0, right?
Perfect. Yeah, right here. It's this guy here. That is above 0. It's always the one in front of x squared. And so we know that this guy goes like this, right? So there's a minimum value. There's a bottom to this. And so now the question is, do we know, anybody, do we know how to find the vertex here? I'll sing, oh, Dylan? Awesome, negative b over 2a. Anybody remember that formula? That gives you the vertex, or at least the x-coordinate of the vertex. That's it. It's just a little formula. You got this whole complicated equation right here with decimals inside it, and it's just a negative b over 2a.
Sorry if I found having trouble understanding the problem, but what exactly are we trying to find the minimum cost for the minimum cost of what?
Sure. It is.
Is it minimum cost for maximum profit?
Let me read the question here. So how many fixtures should be produced each day to yield a minimum cost? So we're not going to try to find the minimum cost. We just need to know how many need to be produced. So we're going to find. So on this one here, this is a function of cost, right? It's x. Oh, Dylan, write this in because this will help here. X is the number of light fixtures that need to be produced, and the y value technically is cost for us. Okay, does that make sense? And so what we want to do is we want to find the x value because we want to know how many need to be produced to give us the minimum cost. All right, Maddie, pick on you again here. Give me, what numbers would you plug in for negative b over 2a? I'll go with it here, yeah. So this guy technically is the a value, this is the b value, and that's c, it's written backwards. So talk to me, give me what's the plug-in? Cool, okay, I just want to make sure, I was going to trick you. But negative comes from the formula itself, negative comes from the negative 10. Oh. This one's going to be 2 times, what's that guy? 2.25. Perfect. Okay, so let me simplify this here. Negative of a negative is a positive. 2 times a quarter makes 50 cents. And easiest way to simplify, I'm thinking let's move the decimals over. And so this guy moved the decimal over once, therefore it's going to be a moving over the decimal once. So how about 20? So to minimize costs, this manufacturer says we're going to produce 20 a day. If we can produce 20 light fixtures a day, it minimizes costs to things.
Wait, do we not have to now plug in 20 and solve?
No, because the question is, how many light fixtures should we produce to yield the minimum cost? So then the question is, what is the minimum cost? Then that would have been different. Camille, do you have homework questions? You need to write them down as well. Good, okay. That's cool. Okay. And in business, this would be a good way. In business, it's interesting because if you need to produce, let's say, 21 light fixtures a day, right? What happens here? This is what the equation is based upon. Then you probably need another employee in there, right? But once you get another employee, now you're paying that employee, right? So then this takes into account a whole bunch of different things in the process of manufacturing. I think I told you this story before. When I was in getting my undergrad, my professor at Fresno State, super good best friends with the accountant for Nike shoes. They have 96 different formulas that they work with, and that all comes together as their cost. Right? So you have raw material costs on your hands, right? You have workers' comp costs. You have paying the salary, right? You have a distribution cost, to name a few. Right? All these things. So they deal with all that, and then they figure out what's going to be the price of the $300 shoe. Okay. 2.1, are we done? Everything taken care of? We know everything there. Okay. 2.3. Dylan? Yeah, sure. Concept question. Go.
Like I did the problem, sometimes you have to find which way it falls and stuff, and you find the vertex of the axis, or the vertex of the graph, and then you graph it. But we go over one another. I think it's 67 through 79.
Hey, say again, just to make sure I understand. Go ahead.
It's the problem where it's you have to find out which way it falls, falls to the left or falls to the right. Then you find the vertex of the graph, and then you graph it. It's 2.2.
Oh, 2.2, sorry, I'm on 2.1. There you go. That's why we're in a different spot here. Actually, I have those as part of what we're going to do later on here. Let's see. Let's do one, though. Let's do 2.2, number 67. Oh, you know what? Glad I saw that here. 1 second here.
These questions are going to be on the test, right? From this particular portion.
Let's have to look at the study guide to make sure. Sorry, my battery was running low here. That should be a lot better now. Abe, this one right here, something close to that?
Yeah, I want to do.
Okay. 2.267, let's go. This one is sketch the graph, apply the leading coefficient test to which way you're going, find the zeros, and once you do that, then draw a graph of it. There you go. So at this point, we have ourselves an equation. And what the easiest way to do it, as we did on the notes here, we're going to factor out what we can. Camille, pick on you here now. So out of these guys, what is common? What can I factor out? X is good. Yep, X gets factored out. Boom. And Landon, can I factor out anything else? Can I factor out some more?
You can factor out well, you can the right kind of square root of it.
Good job, good job. So you're not trying to square root. You can factor completely and factor the difference of squares. So you're trying to do this right here, right? So I want to just say it correctly here. So
yes, I'm just trying to make it so that it's x minus 3.
So you're going to say factor the difference of squares.
Okay, so yeah, factor the difference of squares.
Perfect. Okay, factor the difference of squares would be x plus 3, x minus 3. So for this one, we know our zeros right away. And so I have a 0 at 0. That's cool. I have a 0 at negative 3. I have a 0 at positive 3. That's cool there. Oh, awesome. This little guy right here. Okay. Where are we at now? Dylan. Dylan, this is an x to the third polynomial. Does it start high, end high, start low, end low? Does it start low, end high? Okay. Starts low, ends high. Okay. Oh, class, remember multiplicity? Remember that? I had a question on Monday for multiplicity. So these guys all have a exponent of 1 all the way through. Charlie, pick on you now here. Crossing or touching? Does it cross the x-axis or does it only touch the x-axis? It crosses. How come it crosses? Odd. That's right. So odd exponents, they cross. Let's write down here. Odd, they cross. Even exponents, they only touch. Are we good? Abe?
How do you know that it starts low and then it's high?
That was something we did all the way when we did this here. So when we have, it was called the power functions here. So any odd function is going to start low, ends high, as long as the number in front is positive. So 8.
So if there was a negative coefficient, then it would start high and low.
Yeah, let's draw these out just real quickly here. So boom, we say this is our function. F of x is equal to ax squared. That's our ax cubed, with a being greater than 0. It starts low, ends high. We don't know what's going to happen in the middle, because the zeros will take care of that. The other one, f of x is equal to ax squared, a less than 0. Whoa, whoa. This is going to start high, end low. And then the evens. We've got to do the evens one real quick here. Sorry, class, what's going on? even functions. Let's do it over here. So f of x is equal to ax squared. Starts high, ends high as long as a is greater than 0. And the last one. This one should also be on your notes here. That's going to start low, end low. You good? Cool. So there's your 4. There's your basic 4. We always work with those basic 4. Dylan?
So if you have a parabola that does go over the x or the axis, then what would that mean? Like if it's like x squared like minus like 5, or it starts low, if it's like the vertex of the parabola is beneath the axis and then it goes above it, what would that be multiplicity?
Let me get to that in just a second. Let me finish up this one real quick here. So Charlie said we cross and we cross. So at this point, if I start low, I'm going to cross this guy. I don't know how high it goes, but I know it has to turn around because it has to cross at the 0 again. And then it has to cross again at 3. And we have to finish up at our other arrow. If we don't, we did something wrong. We're good? So then at that point, then we finish up right there, and perfect. That looks like the next cube. Abe, does that answer your question?
Yeah.
Cool. Dylan, to answer yours here. See, I have some other ones that are, forget that for now. That was my little reset here. Dylan, you're saying if it goes like this.
Yeah.
So you would have 2 zeros here and here, and this would be some kind of leading thing should be somewhere like x squared plus something or other. In this case, maybe it's like this here, like that. Is that what you're asking?
Yeah.
So it's going to have 2 zeros. It's going to start high, end high. It'll have to cross the 0 and come back up to crossing the other 0.
I think what you're thinking about is that when the x equals, the multiplicity is odd and only touches the 0. So does the multiplicity not apply to these ones?
Is that what your question is, Dylan?
I think so, yeah.
I think so. That's good. Well, thanks for your help.
I didn't really know what I was asking.
You can cross a 0, and then you can touch a 0 right here, and x cubed will still work out well.
So as long as one of them touches, then it works?
On x cubed, as long as it crosses here and then touches here, then it's going to work, yeah. The one that we had before, it crossed, and that's cool. And then also x cubed does this one right here. It can actually go through a 0, and then that's it, and it goes like that. There's your x cubed. There's all your different possibilities for zeros for x cubed. Crosses once, crosses twice, crosses 3 times. Dylan, is that good? Does that answer your question? Okay. Hey guys, this is really good. I'm so glad. Kind of go through even the homework here, kind of putting things together here. Okay, using synthetic division, 55, 59. 59 is not part of the homework, so I'm going to go with 55. Is that okay?
Yeah.
55, 2.355. Let me do something really quickly here. I'm going to add more blanks into this. Okay, there we go. 2.355. Ooh, this will be a tough one here. How many got? Anybody finish up the homework for 2.3 number 55? Okay, yeah, this was the toughie of the synthetic division. And here is our answer. Our answer is 1 plus root 3. And we're going to say, so it says use synthetic division that shows that x is a solution to this 3rd degree equation. Tristan, question or no? Okay, good. So I'm going to bring this in. This is a solution. So 1 plus root 3 is on the outside. We do this upside down division. And we go with 1. Ooh, am I missing any degrees? Yeah, I'm missing the x to the 1, or the 1 degree. So I got 1, -3, 0, and then 2. Are we good there? Let's see how this is going to work out. This would be so interesting. You got a 1 plus root 3. Okay, I get to pick on people as we go. So 1 gets brought down, 1 plus nothing is still 1. It's too easy. I'll do this one. I'll pick on myself. 1 plus root 3 times 1 will give us 1 plus root 3. A net. What should go right here? Right over here.
Would that be -2 plus square root 3?
Perfect, yeah. You can only add or combine together -3 and the 1, so -2 plus root 3. Perfect. Oh, and now the fun begins. It's going to be this times this to get us back up to here. Isabel, I think I'm going to have to pick on you for that one. You can do it with me, that's fine. Or you could do it yourself and then just give me the answer. That's fine too.
1 minus root 3.
1 minus root 3. Is that your final answer? Yeah? Okay. Okay, let me do it as well. That would be -2. That would be a root 3. FOIL method, that would be -2 root 3. And that would be just a regular 3. So -2 plus, that's a +1. Root 3 and then a -2 roots. That's true. Okay, 1 minus root 3. Pick on myself again. I'm going to bring this down. Da-da-da. I do have to erase this stuff here. So, who have I not picked on for a long time already? Tristan. I need to multiply 1 plus root 3 with a 1 minus root 3. Oh, and also, Tristan, if you could do it the easy way, because you notice, aren't those guys complex conjugates? Same exact numbers in the parentheses. The only thing that has changed is the sign. That's it. So give me the easy way to do it. Perfect, yeah. So it's a 1 times 1. And then this one's going to be 1 minus 3. That's it, because you just multiply the first and the lasts together. Done. And we get ourselves -2. And Owen, did we prove that x plus root 3 is a solution?
Yes.
Because we ended up with 0 as the remainder. Perfect. Dun, da, da, da. Done. 55 is done. Okay. How many got that one correct when you guys did it on the homework itself? 1, 2, 3, 4, 5. Cool. Okay. Good job, 5 of you. Awesome. Okay. Boom, boom, boom. 2.5. 2.5. And 63. Dylan, it was 63 and then 105?
Looking back on 63, I think I just messed up because I made an error and lots didn't understand it.
Okay.
But 105 I didn't want to understand.
Gotcha. Okay. So let's do that one. Application question again.
Oh, yeah,
Same. Okay. I figured you guys would get stuck on 105. This is a lot, and then big, huge equation. So advertising costs. A company that produces. Let's update our textbook here. Instead of MP3s, how about MP4s? Okay. Dylan caught that joke. Okay. Sorry, Landon caught that joke. Players estimate that the profit function. So this is not profits. Profits are. Whoa, big numbers here. Huge numbers. Oh, and then we have a domain restriction. Look at this. It only works from 0 to 60. So a company that produces MP4 players estimates the profits selling particular model by this one, where X is the advertising expense in thousands of dollars. Use the model, find the smaller of the two advertisement costs that yield a profit of 2.5 million. Nice. So I should write it like this here, profit. First things first is, Maddie, upward parabola or a downward parabola? Does it face up or face down? It's a trick question for Maddie.
Yeah, I'm gonna say up, but
Cool. Okay, I'll rest that just for that. It's not a parabola. Parabola has to have a degree of 2. This guy has a degree of 3, so we only call parabolas degree 2, right? Okay, so this one, Dylan, question? Sorry, you had a question. Oh, okay. Gotcha. Okay, sorry, you were going to ask the question. So I'm going to go like this here. Since it's a negative, it's going to go like this, correct? Starts high and low. So somehow it's going to go, here it's going to go like this. Okay. So class, we're going to spend a little bit of time on this because this is a huge one here. And so to make this profit here, remember this is the p-value. So we're going to have to plug in this right here. So we're going to subtract out this right here, set it equal to 0. And then we're going to combine this together. So what is this going to be? Negative 2,820,000. Okay. I'm just thinking if we should do we set equal to 0. I'm not sure why it doesn't have a calculator piece to it. This would probably be the best done by calculator here. And it's going to be huge done by calculator here. So let's do it. Let's do it. So we set it equal to 0. So if you have your graphing calculator, since you guys finally got some, I'm going to give you my graphing calculator, or at least show you my graphing calculator here. Let's see. It's going to go over here. And we have ourselves this little guy. And so y equals, and we're just trying to find the 0 here. So I'm going to plug in this value. This is going to be huge, right? It's in the millions. And so I'm going to go y equals, so negative 76x to the 3rd power plus minus 2820,000. You guys talk to me. Is that correct? Just kind of check my work. All right. So window. Oh, not trace. Sorry. Window. And we have a domain restriction in our hands, right? 0 to 60. So I'm going to go maybe like negative 10. And I'm going to go out to 70. Just give you a little bit of extra space. We good?
what is that for? Those values?
Sure. So we have this little graph that's going to go like this right here, right? From 0, somewhere along this line, we should have a 0 anywhere from 0 to 60 along our x-axis. So instead of looking at this whole thing, I'm looking just right here because of my little domain restriction.
So if there wasn't a domain restriction, you'd literally just be like looking for a needle in a haystack, basically.
Yes. Then you have to resize the window each time, all the time, and it gets crazy. Now, we have huge numbers on our hands, right? And so I'm really just trying to find a 0, but I'm going to go out. We have 2 million on our hands. So anybody want to graph this by hand? Oh, okay. Okay, we'll do it this way then. 1, 2, 3, 4, 5, 6. And let's see what the graph looks like. Oh, yes. Awesome. There it is, guys, right here. And we want the smaller of the two right here. And so now we get to zoom in. So zoom box. And see this little cursor right over here? That little guy right there? I'm going to make a little box right here. And I need to go above the 0, below the 0, and kind of catch that little 0 right there. Awesome. Okay, and again, bring your calculators in next time. If you need help with this little thing, we'll do it on Friday. So bring now your functioning calculators at work. And then we're going to hit trace. Trace just, not trace. Sorry. We're going to find calc right here. It's this little calc menu on our TI. And we want to find the 0. That's what we're looking for. We have to set a left bound, which means we go to the left side of the 0. Click enter. You go past the 0 marker itself sometime. Click enter. And then you guess, which really just enter again. The TI-83s, they do a guess. The TI-84 says, why guess when you're just going to start solving it anyways here. Whew. Guys, we've done it right there. And so find the smaller, so find the advertising expense in thousands of dollars that would yield a profit of 2.5 million here. So 38, roughly 38,000, 38,500. Expense in advertising to yield a profit of 2.5 million. I think that's kind of cool. Yeah, Bill.
Is there a way to specifically specify that you want to see the x-intercept on graphical calculator?
X-intercepts, yeah. Depending which calculator here, so like this one right here, you click and I have a calculate function based upon my graph, and there's my 0 right here. So I specify I want to find the 0.